Hello. I would like to talk to you about matter, energy, environment constraints on life evolution and human activity. My name is François Graner, and I am from the Complex Systems and Matter Lab at CNRS and Univ.Paris-Cité. And I will first introduce me and my motivations. I'm a biophysicist with interdisciplinary approach. I have been working on developmental biology and evolution, but also, in addition, I am taking part into several debates where science meets society, typically nuclear energy, COVID origin, and what is of concern today, degrowth and the future of research. I'm also doing teaching. You can find my videos on degrowth, and I'm supervising a biology and society course. I would like to make very clear that I do not commit my supervisors. I do not speak on their behalf. And I will try to separate arguments from opinions, and I rely on you to check that if ever I fail to do it properly. As a declaration of interest, I should mention that I'm a member of Association Friends of Degrowth, and a member of a small collective called Passerelle, which writes articles on science and degrowth. And I have been at the origin and one of the scientific advisors of a comics on degrowth, which is called Et soudain le futur, which has been published in 2025 with Mathieu Burnia and Dominique Mermoux as authors. The outline of my talk is as follows. First, I would like to list the biophysical constraints on the ecosphere, which is the part of the planet where we live, and then discuss how life and human activity unfolded within these constraints. So that is regarding the past, and then regarding the future, what are the scenarios that we can envision for the human activity? Then I will discuss the role of research within that frame, and that will be clearly my opinion. All the most, unless stated otherwise, the sources of the information and figures that I will mention are extracted from a perspective paper in preparation with my colleagues José Alois, Petros Chasimpiros, and Thomas Gregor, which is entitled The Physics of Sustainability, Material and Power Constraints for the Long Term. I will interrupt me to ask you whether you have clarification questions. And if you have any, I will repeat them because this seminar is recorded. Do you have any? Not at that stage. Okay, I will go on then. My first part is on the biophysical constraints on the ecosphere. So the ecosphere is typically the very thin layer at the surface of the Earth, that is the upper part of the crust, the ocean, or at least the upper part of the oceans, and the lower part of the atmosphere. And the first rule is that the matter in this ecosphere is conserved in terms of quantity. That is we have 92 natural elements, chemical elements. Here you see the carbon, but you can have the iron, the oxygen, nitrogen, and each of them has a fixed amount in terms of kilograms at the Earth's surface since the formation of the Earth, with some variation, but they are minor. There is an influx and an outflux due to geophysics, volcanism and subduction. Typically 10 to the 4 kilograms per second, which are balanced in average. And you have a flux of meteorites, which is much smaller, of order of kilogram per second. And you have even smaller fluxes due to, for instance, to inward flux from cosmic rays, outward flux from hydrogen, and so on. Now, what changes is the quality. Matter quality degrades in a sense which is very precise, that it gets diluted, oxidized, can be broken. The way the chemical elements are assembled can vary. And in fact, what we human would call the usability degrades, but what the scientists call that the chemical potential. And that means that Some evolution can be spontaneous, and if you want to reverse it, it's possible, but you need to make some effort. That is, you need to provide energy. What is energy? Energy is what measures the capacity to transform the world. And what is even more important in this present talk is the power, which is the rate of action, that is the rate at which you use energy. And if the joule measures the energy, the watt, which is the joule per second, measures the power. And so energy in terms of quantity is conserved like matter, with the difference is that our ecosphere is closed for the matter, but is open for energy. There is a big influx of energy and a big out of flux. And so solar flux, 10 to 17 watt, mostly as visible light. You have a few much smaller fluxes toward the ecosphere, the geothermy coming from the inside of the Earth, 10 to the 13 watt, and the tide deposited by the moon mainly, 10 to the 12 watts. And all these inward fluxes are balanced by the outward flux, which is mostly infrared light, or what you would call heat flux radiated by the Earth into the outer space. And by conservation of energy, these fluxes are equal or almost equal. In fact, most of the sentences I will say today can be corrected by nuances, but at first order, the conservation of energy means that you have equal inwards and outward flux. And like matter, the energy can see its quality degrade. And in fact, all the forms of energy that we know progressively degrade into heat. That is, again, its usability decreases, what the scientists call exergy. So, and it's true both for fluxes, like solar, wind, hydro, and biomass, which derive from the sun, and geothermy and tides, which do not. And also for stocks, the coal, peat, oil, gas, which do derive from the sun, or uranium, which does not. So, in summary, there are two simple principles: the conservation of quantity and degradation of quality. They apply both to matter and to energy. When we talk about energy, we call that the principles of thermodynamics, and for matter, it's about the same. Are there clarification questions? Is it by chance that it's the same flux inwards and outwards? Well, no, it's not by chance. It's not a coincidence. In fact, if at some point, for instance, the inward flux increases, then the temperature of the Earth will increase and it will radiate more until it reaches again an equilibrium where the inward and outward flux are equal. So at first order, it's really equal, and it's not by chance. In fact, in practice, you can have variations and delay for the response. So the equilibrium takes time to settle. So you can have progressive transient imbalance. And for instance, currently we have some global warming, which means a very tiny amount of the inward solar flux is devoted to increasing temperature of the Earth instead of being radiated. Where does geothermy comes from? Well, mostly from the uranium, which has been deposited at the formation of the Earth, but which is radioactive with a half-life of 700 millions of years. So it means after 4 billions of years, there is still some left, less than at the beginning. So that's the dominant reason for the flux of heat from the inside of the Earth into the ecosphere. There is also a smaller part due to the original temperature of the Earth, which was created was very warm when it was created. And but this, if you when humankind didn't know about radioactivity, the calculations about the speed of cooling of Earth, were not compatible with the current temperature that we observe, and or it would have meant that the Earth was very young. And now we have reconciled everything. The geology and the geothermy are both consistent with an age of the Earth of 4.5 billions of years. Now, my next part. How did life evolve and how did human activity unfold within these constraints? Well, life and evolution use mainly very abundant molecules, carbon, hydrogen, nitrogen, oxygen, which do cycle, and it's called the biogeochemical cycles. And life also uses minerals in a dilute form. And so material are used at low power and on slow time scales. And it globally cycles, but part of it is derived for the biomass for to make living organisms, and part of it is makes waste or fossils. So for at the times where wood and plants colonized the emerged lands, and there has been a lot of fossilization, which prepared the current oil, gas, and coal that we have today. And but then the mushrooms arrived and decomposed the wood, and now the fossilization is almost arrested. And so basically, life used, of course, a power which was which was below solar flux by construction, but even much below solar flux, and used very few concentration dilution cycles. The dilute minerals are used under a dilute form. Humans use energy in a very different way. We use it at high power, especially since we use fossil fuels. We have an exponential growth. Here it's a logarithmic scale vertically, which means that each line is 10 times larger than the horizontal line below it. So you see that everything grows quickly, and you see that each time a new form of energy is used, it's an addition and not a transition. And you see also that we are very much dominated currently by the fossil fuels. The way humans use matter is very similar. Again, an exponential growth. Again, an addition, not a transition. We use currently industrially 56 out of the 92 elements. And we use them in alternance, in cycles of high and low concentration. For instance, we extract from mines a dilute mineral, and then we purify it to make ingots. So I want to remind you that we don't produce energy and matter because their quantity is conserved. We extract them, and after use there is less usability, at least for us. And so whatever definition of waste that you take, we accumulate waste. I mean, it's what could be called a senile squalor syndrome. You know, these people who don't throw out the garbage from their apartments, so it piles up, and you can imagine how it looks and how it smells. It's also called hoarding disorder. And so we are doing the same on our planet. That is, virtually everything we extract as matter ends up either in the on or below the surface of the soil, or in the water, or in the air. So if I want to summarize that, here you see the cycles. The raw materials using high power are transformed into high purity ingots of gold, silver, zinc, copper. And then at fast time scales, the industry transform it in using very high power again, and using very sophisticated materials. You make a lot of devices, which almost all end up as scrap, waste. There is a few percent of recycling, which use a lot of energy and matter again, and even what is recycled ends up at the end as waste. So the amount and fluxes accumulate, as I told, in soil, air, and water, and typically the order of magnitude is 10 to the 6 kilograms per second. And it's not sustainable for several reasons. Not that there is an energy crisis, in the sense that the solar input, 10 to the 17 watt, is 1,000 times the current human usage of energy, which is 10 to the 14 watt. The problem comes more from the 56 elements. Most will peak before the end of the present century, and the others will probably peak, according to current models, will peak by early the beginning of the next century. What is the main problem is the destruction of wildlife and even threats on domestic and human lives. And I'm quoting here Rockström-Steffen, a series of articles on this problem. So in fact, the current crisis is a global one. If we think in terms of energy, materials, and environment together. And so now life and human evolutions are strongly coupled. We cannot think about them separately. So I can superimpose the two preceding graphs, or with everything is fueled by the low power density of the solar flux, and which dissipates into heat, but with the use of high power density fuels that we extract from the ground. And so the geochemical cycles are very perturbed. The fluxes of human origin and the amounts of human origin are comparable to the biogeochemical ones. They are of the same order of magnitude. Are there clarification questions? Why is it important to mention the dilution and concentration cycles? Well, that might be clear later. But basically, the main reason is that it uses a lot of energy. I mean, diluting is easy, but concentrating costs a lot of energy and of material. For instance, humans, when you purify gold, you use mercury, for instance. When you get copper, which is 1% of proportion in the ore, then you need to dig a lot, huge mines if you want to have a significant amount of copper, and so on. So it's the question of dilution is strongly linked with energy and matter that you use, and then to the fact that recycling is never very efficient. And for instance, recycling glass, for instance, uses a lot of energy, almost quite as much as preparing glass from scratch. And so life, for instance, uses iron, or it finds it in the food. We find it in the food at low dilution, and then we use it in our body at low dilution without going through ingots, pure ingots. So that means that we have developed very sophisticated chemistry, which is very efficient in terms of usage of material, and so which enables not only to recycle the iron, but also to recycle the chemical products, that is the enzymes, which have managed to use the iron. So everything is recycled in life. Almost. I don't want to say that life is virtuous, because of course there have been examples, for instance, the fossilization, where life did not manage well the waste. Now, if now we want to look at the future, given this analysis of the past, I would like to discuss three scenarios that we can see in the media: growth and green growth that we find in the dominant discourse, and degrowth, which is much more seldom discussed. Well, first, let me try to clarify a very common confusion. We often hear about the limits, the boundaries of the planet boundaries. In fact, these words cover three very different concepts, hugely different concepts, and I want to make that very clear for all of you. First, what we call the hard limits. These are due to the physical principles that I recalled at the beginning. These are actual limits on matter and energy. They won't change. It's due to the solar flux, which is the upper flux that we receive, the total amount of fossil fuels that we can find in the ground, and the total amount of each element that we can find. Now, You have soft limits, which the hard ones are due to physics. Soft ones are due to society, economics, political choices, technical knowledge. It's all the sets of practical constraints, which means that if you want to get more energy or get more matter, you need energy and matter and also money effort. And if it requires too much energy and matter, or also money effort, at some point you will stop extracting. And then its practical limit, of course, that can change with time and depending on the effort and the political choices and so on. And it's, of course, much, much lower than the physical limits. For instance, the amount of copper that is practically possible to dig is much smaller than the total amount of copper that you can find on Earth. Same for the uranium. For instance, you have huge amounts of uranium in the ocean, but it's so diluted that it's not practically possible to extract it. And then you have the third types of limit, environmental ones. And these regard the ability for life. And I refer, for instance, to the Rockström and Stephen articles that I mentioned before. And when you hear that they have listed 9 limits, 7 of which have been passed, the seventh a few weeks ago. If you talk about climate change, ocean acidification, plastics waste, and so on, these are limits which are of not only future limit, but even already limits which are reached. And so within this frame, what is the future of growth? Growth is, for economics, it's a growth of profit or more specifically, formal or informal fluxes of money. But for physicists, it's growth of action on the world, consumption of energy, consumption of matter, production of waste. Their amount and their rate are both growing. And since current human activity is not sustainable, having it growing reinforces this point of being not sustainable. So what some people think is a positive point, the growth, maybe it's positive for social or economical reasons. That's a political opinion. At least for what regards ecology, it's not. And how feasible is it? Well, deep sea mining, polar colonization, asteroid extraction, all the ways to extract the reserves, and at some point, it's true that the hard limits are very far away, and we can grow the economical activity for a very long time if we look only at the hard limits. But in fact, these extensions are incompatible with the soft limits. And when I say that materials will peak soon, it's because of soft limits. And a fortiori, of course, if you want to take into account the environmental limits, which is a political choice, not a physical one, then of course growth is incompatible with it. And it's for these reasons that you hear sometimes the sentence that there can be no infinite growth in a finite world. Well, we often hear as an alternative the notion of green growth, and I would like to make clear that it's not realistic either. What is it? It promises to simultaneously pursue growth, but decrease the overall consumption of energy and matter resources and the goal of decreasing environmental impact. Well, I think that you cannot base a policy only on that promise because there is simply no experimental example for that, no theoretical proof of feasibility. I list one report on waste, for instance, saying that the perfect recycling is not possible and is not reached, and an article on to debunk the notion of green growth. Let's say it's not more realistic than a perpetual motion machine, here depicted on the right by Escher, and which was very fashionable in the 18th century until the French Academy of Science decided that it had ruined too many people. It has wasted too many efforts and time to look for that. And I think if we want to pursue green growth, we will again ruin time, waste time and money, and ruin people, but also ruin the environment. Well, some people want to make believe that the green growth could be realistic by focusing on only one aspect, which is decarbonation. And then they make a much weaker promise to pursue growth, but decrease only the greenhouse gas emissions. But that requires a lot of power of technical materials. It depletes a lot of materials. For instance, currently the orientations to our green growth has not really stopped the greenhouse gas emissions, but it has really depleted the reserves of lithium and copper, which have a very bad prospect. And it is a lot of waste. We are all the devices that we are preparing now for photovoltaic, nuclear, or wind electricity are preparing a lot of waste for the future generation. So, in addition, there are things like the rebound effect. That's if you make more efficient and more decarbonated processes, but you use them more, in the final impact is worse. But basically, there is a kind of limit. I mean, if somebody wants you to focus on decarbonation as if it was a goal by itself, just remember that it's a false good idea in the sense that it's worse for global reasoning in terms of energy, matter, and environment. Can a solution exist with the constraints that I have listed? Well, regarding the feasibility, we know there is at least a solution. Well, of course, there is a solution at zero activity if all the life stops, of course. That's compatible with the physical constraints. But I'm looking for a more steady one. And we know that life has evolved for billions of years. How? The energy, it used only renewable energy flux, in fact, solar flux and its derivatives. But not only that, it's of course not sufficient. It also operated at low power density. And regarding matter, it relies on cycling and or abundant elements, carbon, hydrogen, oxygen, nitrogen, and it avoided switching from low to high concentration. And also, evolution used slow time scales to filter out all the atoms which did not respect that rules and failed at some point. So, if we want to think that perpetual growth is not realistic, that system breakdown is not what really we wish, at least, well, that's my opinion, but I think it's shared by many people, then there should be a sustainability window, which is obeying, not imitating life, not only, but at least respecting the same rule that we know are really sustainable. And so this is called the growth, and because it means that we need to reduce many things regarding human activities, that is decrease the size and scale of our activities, and in fact decrease consumption of matter and energy, but also the power, that is the rate at which we consume. And if we really obey the same principles as those selected by life evolution, it could be sustainable at long term. But of course, it means decreasing qualitatively and quantitatively in a radical sense, and should be global. Maybe transient. I mean, we don't want to go to decrease, go to zero. So it could be possible to reach, well, a so-called steady state. It's not steady at all. I mean, life evolution has never been steady. But I mean something which is in between, not growing and not going to zero. Are there clarification questions? Is surface a constraint? Yes, the surface area of emerged lands is also a constraint. I didn't list it, and there are other constraints too, but the surface is really a very important one. The competition for surface, for instance, the part you will devote to capture solar energy and for machines, and the part you will devote to agriculture, the part you will devote to live or whatever, or to wildlife, all that repartition of the surface is of course a crucial point at the present area where we have used a lot many lands, and the question, for instance, of deforestation in Amazonia or in tropical forest is of course directly linked with the growth. You cannot complain about deforestation of Amazonia if you are a partisan of growth, because it's just absolutely directly linked. You can of course blame one person, another person, but basically it's the will for growth, which is the source of deforestation. The same, it's growth creates more polluted areas, so limits the area which are habitable, and if you have more photovoltaic energy, you capture solar energy that is not going to agriculture and so on. Even if you coexist more or less, you capture the energy related to the surface. Now, I want to address next part, which is, and it's my opinion now, we are leaving the question of the facts, and it's the role of research in that frame. Well, we all know that research activity can have many positive impacts, and I can speak about them for hours, but here we mainly should mention two of them. The fact that research helps to make alerts regarding the future uh, dangers or crises that can arrive, and also research can provide us with new techniques, for instance. There is also negative direct impact. Research now is more and more concerned with the fact that it's an activity which per person uses a lot of matter and energy, creates a lot of waste and greenhouse gas emissions. And so, of course, there is a concern and not many ideas to keep the same activity or let the research activity increase while decreasing its impact. But what I want to discuss now, I think is much more important, much less discussed, is the negative indirect impact of research as a whole. All disciplines, not only those which are doing big science with huge infrastructures. I would like to say that growth and research fuel each other. That in the sense that growth is finances research, and research um, helps to have more offer of new products for growth. But also ideologically or culturally, the ideology of growth favors the ideology of progress and research, and vice versa. The ideology of research favors the ideology of growth. To summarize, research is one of the motors for growth. Not the only one, advertisement too, and some extractivism too, many others, but at least research is one of the important motors for growth. And so, if we think that growth is currently a problem for the planet, then research is part of the problem. So, how can scientists react? Well, there could be some reactions like, well, I want to accelerate. I ask for more money and I will promise to have very nice products or techniques which will save the planet. For me, in my opinion, it's like this headlong rush drawn by Charles Jones. And also, many of us need to protect ourselves psychologically and protect also our self-esteem. And so we could imagine a lot of denial mechanisms, and I know them in me, and I know them in all people who come and discuss with me after my conferences. And so I know that it's very widespread, including in me. Now, in fact, there is a recent trend, and if you look at polls in the recent years, 2022 to 2024, in different countries, in different disciplines, for people with different status and ages, you see that more and more people become skeptical about green growth. More and more people become favorable in principle to degrowth. And even the two curves are crossing each other. Uh, so the fraction of in the academics which favors the growth is really significant now. Still minority, but it's really significant. But we don't see yet any visible consequences in the activity. What could we do? Well, at first you could think, well, we could try to adapt our activity, improve our direction of research, our methods, maybe try to be more cooperative and competitive, look for in research, in our research, look for sustainable scenarios. For instance, question how many persons can the ecosphere feed? For instance, that's a question of research. We could also say, okay, some parts for research have a high direct environmental impact, and so we should stop it immediately, and that would save the rest of the research, like, for instance, geoengineering, artificial intelligence, of course, but also the fusion energy infrastructure called ITER in the south of France, or the CERN upgrade at the border between France and Switzerland for particle physics. You could say that. Well, I would say that it's much more important to think globally about energy, matter, environment, and really, I mean, take some distance and debunk completely the magical thought behind the words like green growth, sustainable development, or energy transition. We should really denounce the will to power, and I think it's our role. We should say that we have to accept limits, whether it's solar flux, matter stocks, the principle of physics. And we can even ask the question that is century old, but has been revived at sometimes, and very notably by the mathematicians Grothendieck in 1971. Should we stop scientific research? And that's, of course, a question for debate. Are there clarification questions? Um, well, yes, I would really say that research is a motor of growth, and that's really why it's finance. If it was not, we would have the same budget like the culture, for instance. We have, in fact, a lot of money. Altogether, research and development in the world receives as much as advertisement, which is 1/3 of the military expenses. And yes, and explicitly, internationally, or at the European level, or at the national level, or regional level, all politicians have the same discourse that research is a way to fuel growth, and it's even considered the internal expenses for research and development are uh, are taken into account by the notation agencies like Fitch, Moody's, and Standard & Poor's for their notes on the economy of a country or a region, which are so important for our politicians. But it takes into account the expenses for research and development because it's considered as an indicator of the future growth. Does it include all disciplines, including human sciences? Well, I'm very uh, used that at the end of each of my conferences, somebody raises a hand and says, okay, but all disciplines are motors for growth, but not mine. And what is yours? Oh, it's geography or sociology or anthropology or what, or psychology. Each of these has been very important, instrumental in growth. Like this very famous book written by a geographer, which is called Geography is Used First to Make War. And of course, geography was developed for colonialism, and geography has been for a very long time some things which was military secret. Maps were military secrets, and even in Portugal, it was until a few years ago. And anthropology is directly linked with colonialism again, and so on and so on. So yes, of course, in all parts of research, you could find some researchers that you think are not related with growth or not, but well, whatever your motivation and the motivation of persons who fund you, whether they are so-called fundamental, that is for curiosity and knowledge, or applied, that is for to produce new techniques or methods, whatever, once results are produced, they are public and they can be used by everybody, and they will be used mostly by the institutions who have the most money and power to use them. And for instance, I have a very good example of my I have always refused military funding, but one of my main articles, of which I was very proud, once it has been published, very quickly, within 2 months, I had the visit of a military lab who wanted to use it to apply it. And I was very surprised because I didn't imagine at all that there was any military application in what I was doing. And not only is that, but no other person that this military lab came and see me, although I thought that there would be a lot of different applications. Um, okay, now my take-home message again, it will be largely my opinion. It will be a summary of what precedes and my opinion. Well, I remind you that there are two simple principles for matter and energy, that the quantity conserves and the quality degrades. And so because of that, you have to think global in terms of matter, energy, and environmental waste. And you have to think from local scale to ecosphere scale. You cannot make another way. And so whether it's green or not, growth is utopic. It's not realistic. It faces limits. Well, physical limits, we don't face them really. At least we have a long time in front of us. But the practical limits, they are very strong. And the environmental limits, they are already reached. And so if you really want, if your goal is to reach long-term sustainability, then the only possible solution I know is degrowth, which means respect the power and quantity constraints and draw lessons from life evolution. And of course, this means self-restraint. This means consumption and inequalities should decrease. Inequalities, if we want that the growth goes well, we should decrease inequalities in order to decrease tensions. That faces a lot of human obstacles, and that's very difficult, I know. You need to change the balance of forces in a very drastic way. But examples of that abound in history, while overcoming physical obstacles, I don't know any successful example in history. And so all that, of course, regarding our activity of research, well, it questions all of our activity, not only the amount of greenhouse gas we emit or the number of computers we buy and throw away. More generally, we have, like for all other human activities, we have to stop the race for power and rather accept limits. If you want further readings, I can suggest the magazine La Décroissance, where I write regularly. With our collective passerelle.ouvaton.org, we have made many articles, including in the conversation.com. I have written articles on this website, piècesetmain-d'œuvre.com, including an update of Grothendieck's question regarding should we stop research. With the collective Passerelle, we have made videos teaching on degrowth, which you can find on Canal UTV, and these comics, Et soudain le futur, by Mathieu Berniat and Dominique Merbout. And I thank you very much for your attention. Questions? Yes. Do I know regenerative economy? Well, it's very recently I've heard about that. It's very recent. I didn't know before. It's supposed to be industry or economical activity which really takes into account all aspects of energy, matter, and environment, and not only greenhouse gas emissions. And first, I would like to say it's very promising in the sense that there is really a line that you can draw between the people who tell you about decarbonation as if it was a goal by itself. Then these people usually think they can go on with growth and they are green growth believers. While persons who tell you decarbonation is very important because it's the first step, because climate change is a big problem, but it's only a first step towards a global analysis in terms of energy, matter, environment, then you are on the good side and you are on the slippery slope, which brings you to degrowth. And so really keep in mind this line between people thinking about decarbonation as a goal and people really thinking globally. So this regenerative economy is thinking in the good direction. Two problems. First, it's very difficult to see how many enterprises and which one can really do that. And if any, it would be a very small number of enterprises. And second, it does, even if there are many enterprises like that, it does not compensate for those which do harm environment daily. So it should be not only in addition of existing enterprises, but instead. And so if you can, all the extractivist industries, you cannot really make them regenerative. So, and they are, of course, big contributors to the environmental problems. Um, how can you diffuse your position on degrowth? Well, well. And how, more generally, how can we hope that degrowth will happen in the future? Well, this comics is exploring one way. That is, there is an experiment on an island here, the Cité Island, for 6 years, and the people around it are examining the experiment, what works, what doesn't work, before deciding whether they want to extend it to the whole country. Well, of course, you know that you need a balance to change the balance of force drastically, but also make all the poor people on the planet, even whether in rich or poor countries, that degrowth is good for them if it's means a better environment and less inequalities, less competitions, and less race for power. But you could try to convince some of the people of the rich class, for instance, people like me, could easily be convinced that degrowth is very desirable because for me, the reason I have opinions favorable to degrowth are not only because I am physicist, but also because I do think that my life would be much better without any social pressure to consume and without the way of life that we have around us. And so, but of course, all that means how do you prepare the ideas? You know that balance of forces changes usually, of course, if the ideas are there, but when there is some accelerator of history. And so I think we need both, and it's very difficult to predict accelerators of history. And for instance, somebody in France in 1787 would have never guessed uh, despite the presence in the air of some revolutionary ideas, you would have never guessed that a few years later, all the nobles and gentlemen would spontaneously, during one night, throw away all their privileges. I say spontaneously, of course, between quotes, because they knew that if they went out of the room without doing that and come back in their castles, their castle would be burned and they would have their head chopped off. So, of course, it's a strong incentive to make spontaneous uh, disappearance of the privileges, but at least they did it. And so, and other revolutions, other strong events were, I mean, in 1913, you couldn't guess the state of the world in 1920, and the balance of force had changed a lot. So I don't know, but I know that it's interesting and pleasant to try to diffuse the ideas of degrowth and to show how that it can be desirable even for our health, for our food, for whatever. And then I think it's well, it's a good, it's a way to end this conference on a positive note. Thank you very much.